Welcome to a lesson with Dr. Powell. Let's see how we can think about the divisibility of one number by another one via a free Z-module map. First, let's take a number like 2,576. This is a 4-digit number with a base 10 representation. We could think of it as 2 times 1,000 plus 5 times 100 plus 7 times 10 plus 6. Okay, now notice that this is defined via addition. So this and this and this and this. Why don't we pull this number apart a little bit and think of it as living in Z4, where each digit is like a component in Z4. So this would be like 2, 5, 7, 6. And we can send this, we're going to send this to an element in Z mod 3Z. And this is going to be sent to, and this is going to be sent to 2,000 bar plus 500 bar plus 70 bar plus 6 bar. Notice that because addition is preserved simply when we go from Z to Z mod 3Z, and you can think of 2,576 as living in Z itself, mod 2576 is equal to this because the operation is preserved, either from the outside of the bar to the inside. And so these two things will be the same. Hence, this map, if I were to define it this way, actually answers the question of what mod this lives in. All I did was split up the digits as follows: 2, 5, 7, 6 in a tuple, but it should answer the question. Now, since this is a map from a free Z module, we should be able to represent it by a matrix, where first we have the image of this map, let's call it F, of E1. Then we have the image of E2, E3, and E4. What does E1 represent? E1 represents just 1, 0, 0, 0, which is equivalent to 1,000. So really, f of E1 should be what mod 1,000 is. What f of E2 should be what mod 100 is. Mod 10 and mod 1. So really what we're looking at is a matrix that looks like mod 1,000, mod 100, mod 10, mod 1 in the respective mod that we desire. That's our matrix. Okay. And then our input's going to be represented by a column, such as 2, 5, 7, 6. So if we think about what that would look like, it would look like a matrix multiplication on the right. 2, 5, 7, 6. Simply going to be 1,000 mod times 2 plus 100 mod times 5, 10 mod 10 mod 3 times 7, 1 mod 3 times 6. And that result is going to give us what 2, 5, 7, 6 is mod 3. Okay, and if it's 0, then we can be sure that 3 is this is divisible by 3. If it's not, then we know it's not. So we can go ahead and perform this. But first, maybe we should simplify this. Because if we could just simplify these, then finding the divisibility of any number would be pretty easy. But mod 3, it's pretty simple, because 9, 99, and 999 are all multiples of 3. Hence, all of these are just 1's mod 3. So for mod 3, the divisibility is very simple. For other numbers, it changes, but 3 and even 9 is the same. It's just a lot of 1's. So really, all we need to do, this is equivalent to just adding up the digits. 2 plus 5 plus 7 plus 6, and looking at the mod. So we add the digits. 2, 5, 7, 7 is 14, plus 6 is 20. Oh, that's not divisible, but that's not a multiple of 3. It's not in 0 bars, so hence this number is not a multiple of 3. But what is it? It's 1 less than a multiple of 3. So to make it a multiple of 3, we just add 1, and we got it. So it'd be, 2,577 is therefore a multiple of 3. Thanks for watching.